The problem is the cost of that magnet. The magnet cost drives the motor cost, and that is an unstable cost. Add in the fact that the supply chain primarily goes through China, so 85% of rare earth magnets go through China at some point in their production, and that means that you've got a single source of failure.
Tell me a bit about this value chain report on e-motors and how it fits into the work you do at the APC.
So at the APC, we regularly produce value chains for different technologies and look at cost analysis across those value chains and where UK opportunities are. We produced a value chain for electric motors a few years ago. It focused solely on permanent magnet motors. The world has moved on a bit there, and there's a proliferation of different designs of motors. So we decided to look at that, to look at the material supply chains as well, inputting into those motors, and did a cost analysis across the full production value chain, looked at where the UK can play.
So what are the challenges around permanent magnet motors and the rare earth elements which go into making them up? And what's the supply chain looking like for production here in the UK?
So first off, if we look at why we're using permanent magnets, right, they're great. So if you use a permanent magnet, you've got a nice strong magnetic field. If you use a rare earth magnet like neodymium, you get a very strong magnetic field. And that ultimately means power and efficiency of your motor. So that's why that is the choice of motor at the moment. It's powerful, it's efficient. The problem is the cost of that magnet. The magnet cost drives the motor cost, and that is an unstable cost. The materials that go into that, the rare earths, they're not mined on their own. So if you think of lithium in batteries, that's something that lithium is produced for lithium in batteries. Rare earths are not produced on their own. They come alongside with other materials, and that means their cost is tied to those other materials. Add in the fact that the supply chain primarily goes through China, so 85% of rare earth magnets go through China at some point in their production, and that means that you've got a single source of failure in your supply chain, and that's a risk, and we saw that risk happen with COVID when supply chains were shut down, so that's a worry that can happen again.
That's permanent magnet motors. What about the other two types of motors? Tell me about those.
So induction motors, there's no magnets there, but the challenge is they won't produce as much power as a permanent magnet motor, effectively from a user point of view. So if you want to try and produce or get to an equal sort of feeling of power, you need to do something clever with the power electronics, and that increases the cost. So theoretically, they could be cheaper than a permanent magnet motor because they don't have the magnets, which are high cost, but you end up adding cost in order to reach that power point. I think we might see that model change a little bit. We're currently in a sort of spec competition where vehicle manufacturers are wanting to have the biggest range vehicle with the most powerful motors and all that sort of thing. I think that will change as we see more cost-conscious purchasing of electric vehicles, and therefore maybe I don't mind if the motors are slightly less powerful and my 0 to 60 is 8 seconds instead of 5 seconds. So that might see a bit of a switch. With electrically excited motors or synchronous motors, they are a bit harder to control, so they need smarter control software effectively. However, that's actually also an opportunity. So one trend that we're seeing is that motor manufacturers or OEMs building vehicles are using the control of the motor to create a different feel. Either they're trying to make it as smooth and quiet as possible, or if you're looking at performance vehicles, sports vehicles, they're using that control to create that sensation of motion, that vibration through the vehicle. That actually, we talk about electric vehicles, people are used to them being quiet and smooth, and say they miss some of the sensation with an ICE engine vehicle. That can actually be replaced through how the motor is controlled.
Tell me a little bit more about those supply chains for the UK production and manufacture of motors.
So the UK, we don't have these rare earths. Well, we probably do somewhere, but not in amounts that we could financially viably mine them. So ultimately, if we're looking at a magnet supply chain, we'd be wanting to work with partners to develop those materials and get those materials in a sustainable way. One of the issues with rare earths that are produced in China is to do with health and safety. So rare earths are often found with nuclear materials, radioactive materials. And so there are safety concerns with how they're mined in China. And also there are hazardous materials that are produced in the processing of these materials. So we want to work with partners where we can ensure these things are done in a safe and sustainable way and develop those new supply chains. In the UK, we can be processing those materials and producing the magnets themselves so that we have our own magnet supply chain with a diverse material input.
And are there any challenges or issues which affect across all types of motor?
Yeah, so every single one of those motors requires electrical steel, or e-steel, as we commonly call it. And that is a supply chain that we don't really have in the UK. So we do produce some steel in the UK, but that's dropped, has been well publicised. And we also have an awful lot of scrap steel, obviously, from all the vehicles that we have and other industries. That steel mostly goes abroad for recycling, and it's generally downcycled as well and not turned into new electrical steel. So what's happening is steel that is produced in the UK that could go into that supply chain is going outside of the UK, and those extra steps of smelting it and adding things like silicon to create e-steel are happening in other countries. We then have to buy it back in at a significant markup. And I've heard that it's sort of twice the price within that supply chain. Now, if we were able to create or accumulate the demand to bring that supply chain back, not only would that give us greater security of supply, it would potentially reduce the cost of that supply chain and therefore the cost of motors going into vehicles. But also it's reducing the amount of carbon that's within that supply chain, because currently this steel is travelling around Europe to go into a motor made in the UK, which seems crazy.